These are the activities from Lesson 8. These problems are all calculator active. The first problem we'll look at talks about high-frequency radiation is harmful to living things because it can cause changes in their genetic material. The following data collected in 1930 shows the frequency of genetic changes observed in fruit flies for the following doses of X-rays measured in roentgens. So we've got a data table, and we're going to plot the data on the grid to make a scatter plot. I typically find it useful to label my axes. So we're going to plot each of the following points as carefully as we can. And then we'll be able to see a trend in the data. In this class, we're looking for a linear trend. Once our data points are plotted, we can draw our line of best fit, which will be a line that we are going to try to keep all of the data points kind of close to, but not necessarily going through any specific data point. So once you've decided on where your line goes, and you're welcome to move your ruler around a little bit to fit it, we can find the equation of this line by picking 2 points on the line, not using data points. So we're looking for 2 points on the line that cross grid lines. That usually makes it the easiest. So the points I'm using are 502 and 4010. Once you have 2 points, you can go through the steps we've done in class to find the equation of the line, starting with finding the slope. And our slope is 0.0023. Next, we can put that into our y equals mx plus b form. And we can figure out the intercept, the b. So we're going to use one of our 2 points to calculate the b. And once we've calculated b, we can put all the information together in the equation. And we'll have the equation of our best fit line. Once we have our regression equation, we're able to use it to predict different percents of mutations. So if we are interested in figuring out predicting the percent of mutations for 5,000 roentgens, we can substitute in 5,000 for X and calculate our Y. Now your answers may differ slightly because your line of best fit may be slightly different than my line. In the next problem, we're using, the table is showing us the percentage of U.S. men who are married by age. The grid below, using the grid below, make a scatter plot. So again, we're going to use our table, plot our points, and produce a scatter plot. And then we'll see the pattern. And while we're doing that, we can then draw a line of best fit. We're going to be careful not to use 2 points of our data set, but instead try to find a line that we think fits all of the data points the best. We then can go through a similar process that we did in the previous problem of finding the equation of the line of best fit, or the regression line. So here's what I think might be the line of best fit for my data points. And now I'm going to find 2 points that are on my line that are not data points but cross grid lines. That will give me 2 points to find the equation of my line. So the first point I'm using is 3890. And the second point is 2430. So once you have 2 points, you're able to find the equation of the line by first finding the slope and then using one of the points to find the B. Find B. Once you have both the slope and the intercept, you can put those pieces of information together to write your regression equation for the line you drew. So our slope is 4.3 and our intercept is negative 73.2. Negative is fine. You can see that it would cross the y-axis in a negative number. Next, we're going to interpret our slope. Our slope is 4.3. And we're going to use our units to write a sentence. So for every 1 year increase in age, 4.3% of men get married. So your percentage of men who get married increases by 4.3% for each 1 year in age you increase. Now we're going to find our x-intercept of our line. So the x-intercept is where our line crosses the x-axis. You can see it somewhere between 16 and 18 on our picture, on our graph. We're going to put a 0 in for y to calculate this exactly using algebra. And we solve for x. X is equal to 17, and we're rounding to the nearest tenth, so 17.0. Now we can interpret this point, the 17.0 comma 0, which says that 17-year-old men, 0% of 17-year-old men are married. We want to refer to both coordinates of our point, so both the 17 and the 0. Now we can use our equation of our regression line to predict how many men will be married at the age of 28. So we're plugging in 28 for x and using algebra to solve that. You can see it's somewhere between 40 and 50 on the graph. So y is equal to 47.2. So 47.2% of men are married by the age of 28, at the age of 28. Use the equation of your line of best fit to predict what age all U.S. men will be married. So we're trying to figure out at what age will we have reached 100%. So we're putting 100 in for the y and solving for x. That comes out to be 40.3. But we're not very confident in the validity of our answer because it's unlikely that there is an age at which 100% of men are married. And our model probably breaks down since we're extrapolating outside of our data.